Good morning, students. Today I will continue with the 2019 Instrumentation Engineering paper. In the circuit shown below, initially the switch S is open. The capacitor C1 has a charge of 6 coulomb and capacitor C2 has 0 coulomb. After S is closed, the charge on C2 under steady state is dash coulomb. So this is a basic problem on capacitor. Now first you understand the problem. So there is a circuit with the initial charge on capacitor plate C1 and no charge on capacitor C2 plates. And there is some voltage on capacitor C1 but no voltage on capacitor C2. First you have to understand the problem. That is, one is charge, another is zero charge. Now switch is closed. On closing the switch, what happens? As the switch is closed, the capacitor which is charged to 6 coulomb has to circulate current. During the process of circulation, what happens? Capacitor C1 loses charge and the capacitor C2 gains charge. How long this continues? Now as C2 gains more and more charge, its voltage is going to build up. One stage, what happens? This voltage becomes equal to this voltage. This capacitor C1 is losing voltage, whereas C2 is gaining voltage. At one stage, what happens? The voltage on capacitor plate C1 and C2 becomes same. Then what happens? Current in the circuit becomes zero. So this is the proper understanding of the problem. Then only the current in the circuit becomes zero. Otherwise current keeps on flowing. Now keeping this in mind, we have to work out this problem. Okay, and ultimately we have to find out what is the charge. So 6 coulombs is the charge. So 6 coulomb is in the system. So it is to be distributed among these two capacitors. Okay, 6 coulombs. 6 coulombs means Q1. 6 coulombs means what is the voltage? We know that Q1 is equal to C1 V1. Therefore, V1 is equal to 6 by 1. So 6 volts is to be distributed. 6 volts is to be distributed among C1 and C2. In the same fashion, 6 coulomb is to be distributed among these two capacitors. So we have to find out ultimately what is the charge on capacitor C2. Now first what I will do is 6 coulombs. So 6 coulombs is equal to, so 6 coulombs is the voltage, is the charge in the system. Now I will assume that the voltage in the system becomes V. Okay, V. Q equal to CV. Q equal to CV. So C is equivalent capacitance of the circuit. V is the net voltage in the system. So if you write according to this, Q6 is equal to C equivalent into V. V means the voltage in the system. What is the voltage corresponding to 6 coulombs? So C equivalent. So C equivalent means, now the question arises, is these two capacitors are in series or in parallel? Now if capacitors are in series, then what happens? If C1 and C2 are in series, what is going to happen is the voltages are going to be different, but charge is going to remain same. This is series arrangement. In series arrangement, voltages are going to be different, but charge is going to remain same. Whereas in parallel arrangement, the voltage remains same, but charges going to be different. In this problem, voltages are same. That means it is parallel arrangement, not series arrangement. Only in the parallel arrangement, voltage remains same. Voltage across the plates of the capacitor remains same. Charges are going to be different. So 6 coulomb is going to be distributed. Later we shall see at the end how much C2 is going to acquire finally. Now what I will do is, I will find the equivalent capacitance. So what is C equivalent? C equivalent means when capacitors are connected in parallel, they can be directly added. So 1 farad, this is 1 farad, this is 2 farad. 1 plus 2, that is 3 farads. 3 farad. Therefore, 6 is equal to 3 into V. Therefore, V is equal to 2 volts. That means C1 and C2 finally will going to have 2 volts. So 2 volts here, 2 volts here, then current in the circuit becomes 0. 2 volts, 2 volts. Now once again we shall apply this equation to this capacitor. So 2 volts here, capacitance C2 and Q2 is the charge. Q2 is equal to 2 farad into 2, that is 4 coulombs. 4 coulombs. So earlier C1 was having 6 coulomb. Now it is going to give 4 coulombs to this C2 and the remaining charge on capacitor C1 will be 2 coulombs. So 4 plus 2 makes 6. So answer is the charge on C2 under steady state is 4 coulombs. So that ends the problem. Thank you.